You wish to estimate, with 99% confidence, the population proportion of U.S. adults who support labeling legislation for genetically modified organisms, or GMOs. Your estimate must be accurate within 2% of the population proportion. Part A. No preliminary estimate is available. Find the minimum sample size needed. For this question, we're going to use the formula n equals p hat times q hat times the critical score divided by E, all squared. When no preliminary estimate is available, we automatically assume that p hat and q hat are both equal to 0.5. Now let's figure out what our critical score is. We're looking at a 99% confidence, so we're going to go to our table and look at the table for the confidence. Here is table 4, and again I'm looking at this table, and I'm looking at a 99% confidence interval. 2.575 is going to be our critical value. The last thing I want to identify is my error. Our estimate must be accurate within 2% of the population proportion. This means that my error is going to be 0.02. It's 2% in decimal form. Now let's plug in our numbers. I'm going to do this calculation here. I'm going to take 2.575 divided by 0.02 and I'm going to square it. And this value is 16576.56. When I multiply these three numbers together, I find 4144.14. Since we're looking at a minimum sample size, anytime we have a partial or a part of a sample, we need to round up to the next whole number. So the minimum sample size for part A is going to be 4,145. Now let's look at part B. Find the minimum sample size needed using a prior survey that found that 75% of U.S. adults support labeling legislation for GMOs. We're going to use the same formula as before. This time, p hat is going to be equal to 0.75, the decimal representation of 75%. Q hat is 1 minus 0.75, which is going to be 0.25. My critical value is going to be the same, 2.575, and my margin of error is also going to be the same, 0.02. Now let's plug these numbers into our formula. In the previous part, I went ahead and did that calculation, so I still have that. And that number is again 16576.56. When I multiply these numbers together, I find 3108.10, which is approximately equal to 3109. So the minimum sample size needed in part B is 3,109. Let's look at part C. In part C, we are to compare the results from part A. Let's list our results from part A and part B. In part A, the minimum sample size was 4,145. In Part B, our minimum sample size was 3,109. Notice that when we had an estimate, what happens to our sample size? Our sample size decreases. Therefore, we can say, as an answer to Part C, having an estimate of the population proportion reduces the minimum sample size needed.